we can use our formulas like this, y equals mx plus c, to find out information about coordinates along a line. So the x-coordinate of each point on the graph of a straight line is a solution to a particular linear equation. So if you were to tell me the y-coordinate is 4, I could plug in 4, it's flipped around, but it's still the same formula. Instead of y equals 2x minus 1, if I tell you that y is 4, that's pretty crude, then we can go through and we can work out that the x-coordinate would then be 2.5. There. And we just use that normal algebra, as I'll show you, to do that. Point xy is a solution to the equation if its coordinates make the equation true. So when you plug in the info and you get the right answer, left-hand side equals right-hand side, then those points are on the line. So every point on a straight line is a solution to the equation for that line. So any point that's not on that straight line, so it will not be equal. If it's not on a straight line, if it's out here or out here, my pen's giving out on me, they're not solutions for that, and they won't add up to be equal on both sides. Now, if you have two lines crossing each other, two straight lines, you'll have a point in common, and this is called the point of intersection. The point of intersection is the exact place, in this case, x is 1 and y is 3, where both of these are true. And how can we do that? We'll substitute 1 in for x, and we'll substitute 3 in for y in both of these different equations. And if they come out true, then that is the point of intersection. Let's do some. So here we've got a linear graph to solve this equation. We've got y equals mx plus c here, and to solve each of the following equations. So if I have, and this is, we're just flipping it around and putting y first. When y is 5, 2x plus 1 equals 5, then we just use our algebra. 2x is equal to 5 minus 1, which is 4, so x will be equal to, divide 2, x is equal to 2 for A. For B, we have 2x plus 1 equals 0. So that's when y is 0, and that's going to be interesting in the future. So then again, we'll get to 2x by subtracting 1 from both sides, and then we'll divide that, and weird enough, divide by 2, that gives us x is negative 1/2. Yes, it can happen. And then for C, we've got 2x's plus 1 equals negative 4. That's a 4. In which case, if we subtract 1 from each side, we get 2x's are equal to negative 5, because negative 4 minus, negative 4 plus negative 4 minus another 1 is like saying, yeah, it's like saying 4 plus negative 1. So that gives us negative 5, and that 4, therefore, ergo, divide 2 on both sides, divide 2, come on, that's negative 5 over 2. We could leave it like that. Does it tell us what we have to do? Or we could turn it into a decimal, or what would that be? 2 and 1/2, I think. And now for this one, we have two graphs. Use the graphs of y equals 4 minus x and y equals 2x plus 1 to answer these questions. Write the coordinates on 4 points, the xy coordinates, on the line with equation y equals this one. So I'm going to choose 4 points. I'll choose that one. So for A, I can choose, what is that, 0, 4. Here we go. 2, 2. Let's choose that one because he looks important. He would actually be, I probably should write this in a different order. What is he? 1 on the x and 3 on the y. And then we'll do this one, which is 4 on the x, 0 on the y. Now we're going to write 4 coordinates for this one. I think you're going to see we have one in common. So this one way up here crosses directly through 2, 5. We'll reuse this one, as you can see. That's going to come out as a common point. We also have this one here, which is, let's see, x is 0 and y is 1. And then There's another one where it goes through directly one whole one. It looks like -1, -1. We can have halves. No problem there. Write the coordinates of the intersection point and show that it satisfies both equations. Okay, so the intersection point is, we said it was here, and the coordinates for that are 1, 3. Now to show that it satisfies both, we're going to have to write our equations. Y equals 4 minus x, and y equals 2x plus 1. And if they're both true, then we've got something. So in this case, x is 1, y is 3. X is 1. 4 minus 3 is 3. And this one, what we say, y was 3. And that's 2 times 1 plus 1. I think you can see where we're going, is 2 plus 1. And so therefore they are equal. And finally, solve the equation using the graphs. So we're essentially saying that this is true because if y equals that, 4 minus x, and y equals 2x plus 1, then they should be equal to each other. And we can find out what x is. We can solve for x using that truth. So for D, we have 4 minus x equals 2x plus 1. We want to try and get all our x's on one side, and I like to keep my x's positive, so I'm going to add an x to both sides. That'll give us 3 x's plus 1. Then I'm going to subtract 1 from both sides. Subtract 1 with this pen, it's just given out, which gives us 3 equals 3x, and I think you could probably work out from there that x is going to be equal to 1 because we can divide both of these by 3. Which of course it does equal 1 because